I'm truly honored to be invited to speak here. This is not my first Step In Summit. And, and I'm choking up already here. But, it could be my last because in the introductory remarks there was this focus on young leaders. and I'm not getting that way anymore. Like I say, it's an honor to be invited here. My connections with India go back more than a quarter of a century, and have visited your wonderful country and seen its sights and met its people on multiple occasions, and always thrilled to be back. So my talk is called The Mismeasure of Software, and it's subtitled The Last Talk on Measurement You'll Ever Need to Hear. And there's really a subtitle under that, and that is, If You Pay Attention. If you'll listen to what I say. I gave this talk recently at the Star East Testing Conference, and 10% of the audience hated it. I think they were all the metrics people. So how many of you out there are metrics people? That's primarily what you do, is metric stuff. Raise your hands high. Now I know who. All right. So let's talk a little bit. We're going to talk about four basic topics. What is measurement? The four don'ts of measurement. My favorite indicator, which turns out not to be a measurement. I'm going to conclude with what I call Lee's zeroth law of measurement. So let's start. What is measurement? Well, my friend Kim Kainer has one of the better definitions, I think. He says measurement is the empirical objective assignment of numbers according to a rule derived from a model or a theory to attributes of objects or events with the intent of describing them. Now, I know that's a mouthful, that's a lot of stuff, but I think that's what measurement is. It's the assignment of numbers, not just randomly or arbitrarily, but according to some rule or based on some model or theory to attributes of objects or events. And why do we do this? We're trying to describe them, trying to speak with each other about them. Now, before I talk about software measurement, I want to talk about phrenology. How many of you are familiar with the Western science of phrenology? It's the measurement of bumps on the head. And it was very popular back in the late 1800s, early 1900s. There were these scientific theories that things about your brain were actually essentially knowable, visible on the outside of your head. And so let me give you some of the basic ideas, the basic foundational beliefs of phrenology. First is the brain is the organ of the mind. Would we believe that today? Would we accept that idea? Okay, so that's kind of in green there. The brain is not a homogeneous entity, but it's an aggregate of mental organs with specific functions. I think we know that. There are specific functions of thinking that are localized in different parts of the brain. And these organs are topographically located. There is a speech center, and there is a hearing center, and there are other centers in the brain. I think these things are well known medically. Now the color changes. Phrenology teaches that the relative size of any particular mental organ indicates the power or strength of that organ. Medical science does not bear that out. Okay. And a final idea of phrenology is that external measurement can actually be used to determine the internal states of our mental powers. That is, by feeling the bumps on your head, I can tell about your mental powers, perhaps even your testing abilities. So here's a picture that I found, and I wonder would somebody in the audience like to volunteer to sit here and be my subject of an investigation? Raise your hands, would you? No, I haven't called on you yet. Oh, here's a lovely lady. Would you come up? I like the ladies. I'm sorry. Thank you. Hi, I'm Lee.
I'm Sonal.
Sonal?
Yes.
Oh, that's a lovely name. Does it mean something?
It means something pure like gold.
Oh, fantastic. All right. Would you mind sitting down? And just sit right here. And with your permission, I'm not going to hurt you or harm you or anything. I might embarrass you a little bit. So what we're going to do is we're going to look at this map and check out some. So the first one we're going to look at is cautiousness. Now, if I could have you sit just kind of straight up. And cautiousness, you see, is kind of right here, and nothing. Nothing at all. All right? So we now know something about something. Let's look at this next one. Kindness. Now, kindness is kind of up here on the top and the front, right? Oh, I can feel something there. That's good size. All right. So now we know a little bit more. And now let's go to this third one here. This is, I know you can't see it very well, but it's sexual love. And that's right back here. Oh, wow. This is big. Big bump. So, would you like to have dinner with me tonight?
No.
No? All right. Thank you. Can we give her a round of applause? So, as you see, this science doesn't work. Right? We tried it on this willing subject here, and then it just doesn't work. All right. Like so many other sciences. Now, I want to talk a little bit more about phrenology. Like I say, this was very big in the United States and Europe, into the 1800s, early 1900s. Presidents of the United States would go to have their bumps read. World leaders would go to have their bumps read. Politicians, statesmen, people of power and authority would go and have their bumps read. Okay? It got to the point where they built automated devices. They couldn't do this manually fast enough. And so they built automated devices to do this phrenological analysis. The first one that was built in 1934 cost $200,000 US in that money. So I want you to catch this idea of automated. Okay? There was also a movement among some employers to require certifications of their employees. You had to go and get certified that you had the appropriate bumps on your head. Now, as testers, have you heard these words before? Automation and certification. Okay? I'm not going to say any more about that. I'll just leave that on the table. All right. Now, something curious about Kempkaner's definition. It requires intent. It says the intent of measuring is to describe. It doesn't say it actually describes. And phrenology certainly has the intent of telling us something about human beings, but it doesn't. And so good measurement, a good measurement process, a good measurement scheme will not just have the intent, it'll actually work. Okay? It'll actually be useful for something. Okay. Now, there are two basic causes of measurement error, and they're called the map territory error and the reification error. I want to share those with you. Do you have Sesame Street in India? Yeah. So you know who the Count is? He's a little guy who goes around counting things. All right. So let's talk about map territory error. Again, going back to Kaner's definition, measurement is blah, 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 according to a rule derived from a model or theory. So the question we want to look at is, well, what is the model and what is the theory, and how well does that match? Oftentimes, people confuse the model for the reality. Anybody speak French here? Do you know what that says under the pipe? It says, this is not a pipe. What is it? It's a picture of a pipe. It's a drawing of a pipe. It is not a pipe. Right? The map is not the territory. In the army manual that Swedish soldiers get, it says, if the map ever differs from the territory, believe the territory. Right? If your feet are wet and it doesn't have a stream or body of water on the map, believe that your feet are wet. Right? The reality is the reality. Mathematical models, simulations can all help us learn. But that does not mean they are reality. And the classic example I always use is, remember in your early school, you learned about the atom. Remember the atom had the nucleus. It had protons and neutrons, and it had these little whirly things, the electrons that were going around and around. It was like a miniature solar system. That's a wonderful model. Is it correct? No, that's not the way atoms are. It turns out it's correct enough for most of physics and chemistry, but it's not really the way the world is. Okay, so, but somebody once said, maybe I've got it right here, all models are wrong. Some models are useful. So we need to remember that. All models are wrong. They're wrong in certain aspects, but that doesn't mean they couldn't be useful. But don't confuse model with reality. The model, the theory, the map just could be wrong. Just could be a bad idea. Okay? Phrenology is a bad idea. It's just wrong. Okay? How about another one? Reaganomics. I don't know if you remember, if you know enough about our President Ronald Reagan. He had this thing called the trickle-down theory of economics. The idea was if you gave rich people lots more money, that it would then trickle down to people like me and you. Okay? Now what Reagan forgot was that the way rich people generally get and stay rich is by not letting it trickle down, right? They keep it. So there's a theory that, great. I mean, the guys are laughing here like, boy, did we pull one over on the American people. All right. Neuro-linguistic programming. Lots of people buy into this. You can tell what a person is thinking, but you ask them a question, you watch their eyes. If they look up and to the right, that means something. If they look to the left, that means something. All kinds of things. I don't believe it. All right? Another one that's been a favorite for years is subliminal advertising. At the movies, we flash a message just for a fraction of a second on the screen. You are thirsty. Okay? And it's not enough for the brain to see it and understand it, but the unconscious picks that up and goes, I'm really thirsty. I think I'll go out and get a soda. So, let's go back to Kahner's definition here. There's another problem with metrics, and that's this reification error, and let's talk about that. Measurements empirical assignment of numbers according to rule attributes of objects or events. Objects or events with the intent of describing them. Reification error occurs when we treat an abstract idea as if it were a concrete reality, and we start measuring things about it. Okay? You can't count. You can count chairs. Right? This is not abstract idea. We could go around this room and count chairs, and we could be pretty accurate about that. Or we could count people in the room. Okay? We could count light bulbs. We could count all kinds of things. But counting ideas is very dangerous. How many ideas did you have today? 6. How many ideas did you have today? 10. Ooh, who's the better thinker? All right. Reification is when we start treating something as a physical object. And we start attributing. We try to start measuring things. Counting those is dangerous. That's where the little count guy comes from. And then comparing those counts, like 6 and 10, is even more dangerous. I went to the doctor the other day. I'm getting old, I'm creaky. And I went to the doctor and I said, Doctor, it hurts when I do this. And the doctor said, Don't do that. Right? Notice the difference. See, this arm can go up here, this arm can only go to about here. Don't do that. Well, counting ideas is dangerous. Comparing those counts with each other is even more dangerous. And so my best, simplest advice is, don't do that. It'll get you into trouble. And let me show you some examples here. How many of you have had your intelligence measured somewhere in your life by some test or scale or evaluation? How many have had intelligence measured? Say? What's that?
Every year it will be measured during appraisals.
Oh, okay. Do you believe that that's real? Do you believe that somebody can say, you're 116 and you're 118 and I'm 152? Do you really believe that? No. I mean, it's convenient for kind of categorizing people and saying, well, they're kind of dull, don't want to hire them as testers. How about performance? How many of you have like yearly performance appraisals in your organization? Oh, almost everybody on that one. All right. And do you have categories like excellent, outstanding, fair, poor, things like that? Or maybe numbers, 1, 2, 3, 3.5, 4? Do you really believe that an entire span of 2,000 hours of your effort can be boiled down to a single number or a single word? I don't. Unless, of course, it's one of those good words, like excellent or superior, then it's okay. All right. How about commitment? I've had this one. My boss called me into his office one day and said, Lee, you're just not committed to the organization. Not really wanting to enter into a dialogue with this guy. I said, what's my commitment number? Am I a 12 or am I a 23 or am I a 807? What am I? And it kind of took you back. Well, you're just not committed. You're not motivated. You heard that one? Or maybe you've said that to someone. Okay. When we talk about commitment motivation, we don't know anything about those. Those are internal. A person's commitment is not external, it's internal. Now, what you could say is, I have observed that you only come into the office 3 days a week and you come in late and leave early. To me, that means you're not committed. Okay? But when we make measurements, we need to make measurements of actual things we can observe, things we could document. We can even take little video movies of that and show the person coming in 3 days a week and late. Okay? What are some of the others? Leadership. This person does not have good leadership skills. Oh, yeah? This person is a great leader. Oh, yeah? Yeah. What we're really asking, what we really should be talking about is what are the external observable features. This person can get thousands of people to follow them, no matter what they're preaching. Sounds like a good leader to me. Okay? This person can organize. This person can get people to work together, people with different viewpoints, with different backgrounds, with different needs. This person can get them to work. Great. That sounds like a leader to me. But to say that you're a 3.0 in commitment and a 5.6 in leadership, it's just silly. And yet, many metrics programs do this all the time. Okay? Attitudes, the last one on the list here. You have a bad attitude. I say that to my grandkids all the time. Okay? You have a bad attitude. What I really should say is, the last 17 times I've asked you to clean up your room, you have ignored me. Okay? That's tangible, right? That's real. I count those. But we kind of lump it into this bad attitude. Don't do that. Remember, don't do that. All right. So this is the idea of reification error. It's when we try and assign numbers. We try and assign counts to things that are just ideas. And sometimes not very well-defined ideas. I'll bet if we took the time, it would take us hours to try and define what these words meant, intelligence or commitment. I don't think we could do this in 20 seconds because we all see these things differently. Now, do you understand why you feel so violated after your annual performance review? Okay. Because people have taken these, maybe you didn't, maybe you only did show up at work every 3 days, but rather than talking about that, they commit this reification error. They count things, they count ideas, things that are not real. Again, don't do that. Okay. Now, they are not the only ones that do this. We do this too. How many of you count requirements? Count defects. Then divide them like defects per 1,000 requirements or defects per lines of code or whatever those things are, right? Defects are not things. They are ideas. They are concepts. And if you've been in this business for a while, you've experienced that what one person thinks is a defect, the other one might not see as a problem at all. You have that experience? Okay. So we do this stuff all the time. This is just human nature, to make reification errors, to count things that are not real. Okay? Just think about requirements, for example. Have you ever seen a little teeny tiny requirement? Ever seen a big giant requirement? This is one requirement. This is one requirement. Come on, that doesn't make any sense, does it? Maybe at least we should say something like tiny, small, big, gigantic, something like that. Okay. But just counting these. And defects. Okay. This word on the screen should be yellow-green instead of light yellow-green. Okay. The airplane falls out of the sky. 2 defects. I don't think so. I don't think so. Okay. We do this too, and that's what I want to warn you about today. Okay. So that's my scheme. That's my talk about measurement. Now, I want to identify what I call the 4 don'ts of measurement. And one thing I learned in how to be a good public speaker class is that you should always have clever labels for ideas so that people can kind of grab onto them in their minds. And so I have clever labels for these 4 ideas. Don't number 1, don't number 2, don't number 3, and don't number 4.